I think probably what makes 910 STEM unique is the focus on problem solving. We try to get students to identify problems, complex problems, and find solutions. It starts small with little design projects, but it builds from there. And it becomes more and more complex, and it's pretty gratifying to see the solutions that come from the students.
These problems are applicable to the real world. So the work that they're doing in the 910 STEM program would translate into their further work in their junior and senior year, and then also into the real world when they go off to college or into jobs.
We have a lot of projects that involve building things. So we go along and let the students work in groups, and they start from ground zero where they make a plan. Then we revise that plan, make sure it'll work, and then we have them build it.
STEM has unique unique assignments and unique projects you have to do that like no other core has. It usually uses like science, technology, engineering.
I think what students appreciate is that in 910 STEM, the focus is on finding their perspective and finding their unique way of looking at the problem. There's not necessarily a right or wrong answer. It's more about finding things that work, things that make sense, and things that you can justify. So there's a lot of student choice in the directions that they take.
So I would say in 910 we're trying to build the basics for them. We teach them all those soft skills like how to work in groups and time management and all that kind of stuff. So we really work on that, and then later on they could get more into the technology side of things.
It's like they give us a problem to like basically solve, and it's like they give us a really small amount of time, so it's like a fast-paced moving environment, and so it's like kind of stressful and kind of fun at the same time.
We're also trying to challenge the students' critical thinking skills so that they can approach a problem from many different perspectives, and also be open to solutions that they may not have considered initially.
We always start with a big design project. This year, for example, it was a labyrinth project where they had to build a board game, a labyrinth, and it had to tell a story. It had to have certain elements, pitfalls, changes in elevation, gates, and the kids had to figure out how to make that work and also connect it to kind of a larger story.
So we're working on a labyrinth for a moon landing. I'm gonna have a ping pong ball go through whatever our pathways are to have like a story plotted out.
How would it work from paper to material? How smoothly would things work that you thought would work? Some things go wrong, measurements go wrong, mistakes happen.
So first we planned out our ideas. We just had to put them all on paper, look up like how many astronauts normally go to the moon, how long it takes for travel time.
Do all the planning, all the research, and you have to build, and then you have to finally build it, which takes some time because your plan isn't really, like, doesn't execute as well as you thought it would be. And so you have to make like substitutions, you have to like, if there's no materials left, you have to find a different materials, all that stuff.
Because it's really hard when like there's multiple computers and things working together to not contradict each other or have this thing happen over here when really it's supposed to happen over here.
You know, working with a group, especially when it's your core and you know pretty much everybody's name, you know everything about them. It's pretty comfortable work environment. Everybody knows each other. Everybody's really nice to each other. So everybody has a set amount of respect for each other.
In my English class, I'm really working with the students to develop their observational skills as far as reading is concerned, and then really trying to help them to express themselves clearly in writing and in speaking.
For 10th graders, they also have biotech, so they do build in that. A lot of students take that, so that is also an add-on. We have a range of students. We have every type of student you could think of, ones with like high energy, ones that are more introverted and like to do things on their own. But I think it's just people that like to solve problems. Anyone would thrive in this environment, but it's mainly geared towards those students that like to build things and work with their hands and start from ground zero and then execute.
It's either you're really chill or you're really like energetic, and like that's kind of a good mix, I guess, because like you have the chill people like doing all the research, you have the energetic people like putting out all these ideas and all that.
So again, problem solving, like looking at what are the potential problems and then how do you plan for those.
Building them from the ground up, trying to teach them how to work in teams and how important it is if you don't get along or you don't, there's one person not doing a lot of work, how to work through those challenges.
Well, I think at the end of the 2-year program, students are coming away feeling like they can tackle problems, like they're not overwhelmed by it, but have a path. They know how to tackle it. They become good critical thinkers and good communicators of their ideas, because that's a big piece of it too, which essentially makes it so that when they get into 11-12 STEM, they're ready to go with the bigger, more complex, more kind of math-based type projects, the engineering stuff. So it just sort of sets them up to be really successful there.
I think, STEM really focuses on curiosity. And so we're really trying to nurture curiosity in our students, both about problem solving, but also just about human relationships, the way the world works.
To change your plans, because sometimes they work and sometimes they don't. So you might draw it all out and then work on it and it's not there. And also just working with a team and collaborating, which is what STEM is about.
Well, yeah, I'm focusing on the engineering career path, so it's really helps you prepare for that in college.
I think one of the things that surprises people about 9-10 STEM is that it's actually really kind of focused on humans. It's not just about technology or science. It's what drives us, but it's really about how do we help humans? How do we take science, technology, engineering, and math and use it to make the world a better place, to make it more sustainable? So there's a softer side of STEM that a lot of people don't necessarily think about that I think is incorporated into everything that we do.
How well can you work together as a group to solve a problem? Because by yourself, you can only do so much, but with others, you can do so much more. And that's really the whole core of it, is working together to succeed.